Well, hello there, folks. I hope you're doing well. In this video, we're going to be talking about Chapter 7.2, Describing Angles. In your workbook, you'll find this on page 188. So let's start off with the try these. And you are going to need a protractor, so if you don't have one, pause the video, go grab a protractor, come right back. Try these. Which angles of these four angles form a right angle? Well, sorry, I have the wrong tool up. Just give me half a second here. We gotta switch back to my pencil or my pen. So if I look at here, I have my right angle, which is shown with the little square. So 2 and 3 are angle 2. I should show that angle 2 and angle 3 form my right angle. Now it asks which angles form a straight angle or a 180 degree angle. So right here, I see these two make a straight angle and these two make a straight angle. So there's actually two different answers. So angle 1 and angle 2 form a straight angle, and angle 3 and angle 4 also form a straight angle. And then finally, which angles share a common side? Well, angle 1 and angle 2 share a common side, this side here. Angle 2 and angle 3, sorry, let me rewrite that. And angle 3 share a common side right there. Angle 3 and angle 4 share a common side right here. And going all the way back to the beginning, angle 1 and angle 2, and angle 4 also share a common side.
Do you want any of these? No. Okay, we should try this one.
I'll take care of it. So, moving on from there. Angles are often described in pairs. In this sketch of a construction crane, angle ABC and angle CBD are adjacent angles. Now, it's important to note that when they're listed like this, so with 3 letters, it's technically the inside one is the one that we care about. The reason that they list it is because if we look at angle B could be this one here, but it could also be this one here. These are both technically angle B, or this one here, or this one here. So by specifying the other two parts, the A and the C here, and the C and the D here, we're told which side we want to look at. So let's start with just looking. Angle ABC is this one going up here and across here. So, oh wow, sorry. I'm gonna switch colors. I'm gonna just quickly switch colors so maybe it shows up a little better. Let's use a nice bright red color. So angle ABC is the angle of B. What in the world? Sorry. Last thing, we'll get this here. Is the angle made from A and C connecting through B. So this is angle ABC right there. And angle CBD is the angle formed between C and D passing through B. So it's this angle right there. They are adjacent angles. Those are angles that share a common vertex and a common arm. A vertex is a point. An arm is just a line. So if I look, what are my common arm? C to B is in both of them, and the common vertex is point B right there. Name another pair of adjacent angles. So we have a few options to choose from, but one of them we could choose from is the angle that uses, angle CBD. So we'll go back to CBD, this one right here. And angle DBE. So this angle right here. So here and here. This is CBD. And this one is DBE. They share a common vertex. The common vertex is once again B. And they share a common arm, which is BD right here. So, actually, let me write that down. So angle, pardon me, CBD and angle DBE are going to be adjacent angles. Now it says name two angles that are supplementary. Supplementary angles are two angles whose sum is 180 degrees. And wouldn't you know it, these two angles, CBD and DBE, will also add together to make a 180 degree angle. So CBD and angle DBE, also supplementary angles. Name two adjacent angles that are not supplementary angles. So we need two angles that don't make a straight line. If I, now my thing's kind of making a mess here. Getting a little messy. Probably should have made a second layer so I could have erased it, but here we are. So I'll try and cover up some of this mess here. Not really sure if that helped, but going back kind of to our original here, two angles that are next to each other but don't make a straight line. Well, angle ABE, so let's get back in our A. And let me switch back to the red here. So angle ABE, so this one right here, ABE, and angle DBE, so this one back up here again, they don't make a straight line. If you look at it, it makes this crooked line. So it's more than 180 degrees. They are not supplementary. So angle ABE and angle DBE would be an example. Then finally it says connect, I guess not finally, second last, it says in number 4, connect C to A and E to A to form a right angle. So I start at C, connected to A, and then I start at E, connected to A as well. And it tells us that this forms a right angle. And then asks, what are two adjacent angles that are complementary? Complementary angles, it tells us over here, are two angles whose sum is 90 degrees. Well, we have to think about this a little bit because we know that this is 90 degrees, but this is just one angle. It's angle A. So we need to find two more angles that are 90 degrees. If we look carefully, and hopefully this isn't too messy for you guys. If we look carefully, let me actually clean it up. I'll get rid of some of this in-between part. So, it's my first day. No. So let me just clean this up so we have a good look just at the triangle itself. If I can. So if we clean this up now, get rid of that middle part so it's a little less distracting, we do have a triangle here. Triangle ACE. So triangle ACE is going to hold the answer for us. If angle CAE, so this is angle CAE, is equal to 90 degrees, what are these two angles right here? We know that a triangle, in a triangle, so in a triangle, all angles add to 180 degrees. So if angle CAE is a right angle or a 90-degree angle, well, what do we have left? 180 degrees minus 90 degrees is equal to 90 degrees. That means that this angle here and this angle here have to equal 90 degrees when they're added together, because we have 90 degrees left to work with. It's kind of a, I don't know, not the most obvious way to go around it. And if you use a protractor and actually check your angles, assuming you used a ruler to connect your dots, you'll find that these two angles do indeed add up to 90 degrees. And two angles who add up to 90 degrees are complementary. So angle ACE and angle AEC come together to make complementary angles. And luckily, you do have this in your notes, and you're able to refer to this while you do the practice questions. So, the one example. Calculate the measures of angle 1 and angle 2. And they kind of walk us through it. What is the measure of angle 2? Well, if you look here, we have a 90-degree angle sign here, which means that angle 2 plus this angle here are going to add up to 90 degrees. Therefore, 90 degrees minus 56 degrees is going to give us the measurement of angle 2, and minus 90 minus 56 is 34 degrees. Perfect. Now, what is the measure of angle 1? If you look here, this is a straight line. I didn't draw it straight, but it's a straight line. What does that tell us? That tells us this whole thing here is going to add up to 180 degrees. Which means, to find out what angle 1 is, we just take 180 degrees and we subtract our three angles that we have here. So this is 4 degrees. So we subtract 56 degrees, we subtract 34 degrees, and we subtract 46 degrees. And 180 minus 56 minus 34 minus 46 gives us an answer of 44 degrees. And that's it. So that's it for example 7.2 or chapter 7.2, describing angles. Make sure you do the practice questions. This is all about the vocabulary right now, so that's what you want to focus on. If you have any questions, let me know, of course. I hope you have a fantastic day, and I'll talk to you later.